Today we are going to learn about array search algorithms. These are some of the simplest algorithms to learn about when you get started on data structures and algorithms. So if I wanted to find a particular element, if I wanted to find the position of a particular element in an array or a list, it's as simple as this. All I have to do here is a function that gets in the list or the array, as well as the number I am looking for, which I'll call the target over here. And now we'll just pass through that entire array. So for index in, all indices in that particular array, we'll just go ahead and check if that item, right? If the item at that particular index is equals to the target. And if it is, we will return the index. If we go through this loop and we get nothing, then we'll return none. This is how simple it is to do an array search, simply. So if I was to run this code from my list looking for the number 10 here, it's supposed to give me index 4. And when we run that, we will get our output as 4. However, in practice, that linear search is not the most efficient algorithm in searching an array. Think about how you look for a word in a dictionary. If someone presented to you an ordered array of numbers, just like you're looking for a word in a dictionary, do you start looking for the word mango from page 1? Or do you usually open the dictionary somewhere in the middle and determine what letter you're on, then decide whether to move to the left side or the right side? That's usually the better way to look for a word in a dictionary, and that's also going to be the same principle that allows us to find an element in an array better. So here, when I'm given an array like this, instead of looking for it from the beginning, I could easily come to the midpoint very, very fast, and I realize it's 34. And ask myself, is the number 10 likely to be towards the left or the right? And in this instance, it's likely to be towards the left. So I go ahead and do away with everything towards the right. And now, in the same breath, I also come here and I come to the midpoint again and I ask myself, is that number 10 likely to be above 6 or below 6? Because likely to be above 6, right? I will remove that midpoint and the rest all through. And then I come to the final bit where I go ahead and realize that my midpoint now is 10, right? Which means I've found the number. Now, this is how to implement this. In your typical linear search, you have to do n operations in the worst case scenario, where n is the length of the array. This is likely to happen if the element you're looking for is at the end of the array you're looking for. But in our new solution, which I'm going to call the binary search, you'll only need log n operations, which is way more efficient and faster than n operations. So in an array of 8, worst case scenario, I'd do 8 operations. Now in an array of 8, I am going to be doing only 3 operations. And that number becomes really efficient for instances where n is extremely large. And this is how all that looks like in code. You can pause the screen and just look at the execution on how we track the indices using the pointers here. And you can see when I run this code as well, we also get 4. If you want to learn about this algorithm as well as more complex algorithms, Zindua School has a data structures and algorithms course starting next week, which would be a good ground to get you active on building efficient and scalable code.